What's going on, everybody? This is your friendly neighborhood CSL, Josh, coming at you with a little bit of a discussion on EZC enclosures. Purposes of this video is to give you an idea of what's inside them, how it works, before you go to actually work on one of the enclosures. For all documents used in this presentation, please go ahead and look in the description down below. I will provide a link for you. This is what an EZC looks like from the outside. You'll notice the disconnect is on the front, and then on the side you'll have several of these cables coming into it, one M12 and one flat cable here. This is a better, closer look here, the flat cable and the M12 connector. The M12 connector brings Aussie communications in from the yellow cable, and your flat black cable is what is used to control the e-stop zone that this e-stop zone controller is controlling. The source is located inside of this enclosure. This M12 connector is to tell the status of the power supply located in the EZC, and is typically not used at AVP1. Installing these Aussie cable M12 connectors can lead to issues, so please make sure you take note of what cable came from where if you have multiple cables. Okay, so here's the inside of an EZC. The main power coming in is located right here on these terminals. This is a 120 volt source. Safety note, these terminations are before the local disconnect on the front of the box, so it'll still be hot when the disconnect is off. Proper lockout tagout requires locking out the nearest upstream lockout tagout point when performing work inside of this enclosure. This is the power supply that feeds the power to the e-stop zone. So this is where your 24 volts along the black cable is going to be coming from. This is the Aussie safety module. This is responsible for turning the e-stop zone on and off. Something to note about this, though, is that it receives its power from the M12 connector on the side of the panel and will not turn off with the disconnect. So if you turn the disconnect off and open the door and still see lights on this thing, that's normal. Not a bad thing, but you probably won't see the lights that we're seeing now. Chances are you're going to see some sort of fault. These are the e-stop relays that work with the Aussie controller to turn off the e-stop zones. So this is a possible failure point. If you're not getting your power, it's possible that one of these have gone bad. And this is the 24 volt termination block. All of the 24 volt field connections should be made here. So if you look and follow the wires coming out of your Aussie black cable, your flat black cable that's coming into this unit, it should be actually terminated right here. These two wires right here is where your Aussie cable is getting its power from. The prints for this enclosure starts on page 82 of the document that I included in the link earlier. So if you want to follow along, feel free to go ahead. Okay, this is the page that shows you the 120 volt and the 24 volt circuit. This is how the circuit interacts with the Aussie controller. We're going to go over these in detail in a little bit. This is the M12 connector providing power to the communications in the Aussie controller. As you can see, you're only using 2 of the 4 wires that are inside of your M12 connector. All you really need to provide power to this thing. 24 volts from the power supply feeds through the output relays in the safety controller and feeds the e-stop relays, the coils to the e-stop relays. And this is feedback from the e-stop relays to make sure that they're switching correctly. If either one of the two don't switch correctly, you won't get power here, and it'll pop an error on inside the PLC. So going back to the 120 volt circuit, this is the main disconnect that you will see on the face of the enclosure. There is a little bit of a mistake here though, because the neutral does not actually get disconnected by the disconnect. Only the hot power will. This is the 24 volt power supply. And these are your e-stop relay contacts. Now I want you to take note that the negative wire and the positive wire are both being blocked to the black Aussie cable. So here's a little bit of both. I put both of them on the same screen so we can talk about it. 120 volts flows through here, feeds your power supply. From there, the 24 volts comes out, gets interrupted by your two contacts, and goes to your black cable. Same with the negative, goes through the two contacts here, which in a normal state should be closed. They terminate on these two wires here, or these two terminals here, and go to your black cable. Your positive 24 volts comes out, and through here, from here, it goes over to here, in and out to your coil, in and out to your other coil. These coils engage whenever there's no e-stop present and allow this whole circuit to work. So now we're going to talk a little bit more about the Aussie module. Inside the PLC and OSSIMON 360, you may have seen these being referenced as an OSSD. This is an example of one of those. When replacing this device, it's important to replace it with a device that has the exact part number. Not replacing it with the exact part number can cause a lot of issues. The module inside of an EZC will have a dip switch. These devices have both safe and non-safe components to them, meaning that it'll have 1.5 nodes assigned to it. The prints will show what each node will be addressed as. The O2S in this example denotes that the node 2 is the safety node for this device. So for the device that's listed here, we're going to have 2, 3A. We'll show you how to go ahead and get that in the next slide. So if you flip the dip switch to run mode, you will see the half node that's assigned to it when connected to the addressing tool. So as you can see here in the picture, we've got 3A, and the dip switch is actually switched to run. And if the dip switch is flipped to program, then you'll see that the full node is assigned and what it is. So this is where you can assign your full node, your safety node. You just flip the switch here and you assign it to whatever you need to assign it to and hit right. One thing that you need to know is that it needs to be in run when you're done with everything. Otherwise it won't work correctly, so always make sure that it's in run. Another thing to also take note of, this dip switch doesn't like to be switched. It's actually very fragile, so you got to be very careful with it when you are flipping those switches. So just be extremely careful and only flip the switch if you absolutely need to, which there won't be much reason to unless you're actually switching one out. And that's it. Hope everybody enjoyed the video. I hope you have a better understanding of what's going on inside this enclosure. I plan on doing a short little video like this for all of the enclosures that you'll see across AVP1. Thank you, everyone.